Section 6.6, and this one we're going to be talking about exponential decay. And this one's pretty straightforward. If you understand what growth is, decay is literally the opposite. So instead of being multiplied by a growth factor, we're actually going to be being multiplied by a decay factor. And so if we were to look at this, notice the difference in this equation and the last equation I gave you. Instead of having a plus r, we have a minus r. That means that whatever this is going to give me a number that's less than 1. So basically it gives me like a fraction or a decimal. So let's just say, for instance, that I am decreasing by a growth factor or a decay factor of 0.85. Basically, I'm decreasing 15% each time. That's really all this is. It's nothing too complicated. So if I were to give you, well, matter of fact, let's just go ahead and get into some questions. All right. So in this very first set, it says determine whether the table represents exponential growth, exponential decay, or neither. So if we were looking at this by the numbers, it looks like we're already decreasing each time. So that's cool, but let's find out what we're decreasing by. So let's do a little experiment here on the side. I'm going to say 216 and I'm going to divide by 72. Well, that means that there was a division of 3. So really what's happening on this particular one is, since remember, division is a type of fraction, I'm actually multiplying by a decay factor of 1/3. We could prove it. 216 times 1, and then we're going to put our third in there, gives me 72. And if this pattern continues, we should be multiplying by 1/3 again. So I'm going to times 1/3 again, and we should get 24, and we do. Okay. And then if we do it one last time, we will also see that we are multiplying by 1/3. And since I'm multiplying by a fraction, I'm multiplying by a decay factor, this is indeed exponential decay. Now, if we look at the next one, so we have a 74, 62, 50. Again, it looks like it's decreasing, but let's find out. Let's go 74 divide by 62. That gives me this weird number. So what fraction would that be? I don't know, but it would give me something weird. Let's do a comparison to the next one. So 62 divided by 50, I get a different number. So the ratios between these two things are not the same. But another way I can look at it is I'm actually subtracting 12 each time. This, even though it is a decay, it is not an exponential because I'm not dividing by the same thing each time. I'm not decreasing by the same decay factor. So this is neither. If we were to be honest about it, this is actually a linear equation that we have right here. Same concept here. So right off the bat, we notice it goes 4, 28, 90, 13, 72. So you should realize, hey, this is not a decay, but let's see if it is a growth. So let's find out the difference between them. That's saying that there's a difference of times 7. So 28 times 7 gives me 196, times 7 again gives me, yep. So this would actually be a growth, exponential growth. Looking at the last one, right off the bat, you see that it's going down. So it looks like a decay, and it looks like it's basically multiplying by 1/10 each time, because we can prove that. 3,000 divided by 300 gives me 10. So technically I'm kind of multiplying by a 1/10, and I can continue this pattern, and I notice that I am multiplying by a decay factor of 1/10, or I'm dividing by 10, same thing. So in this case, it is indeed going to be a decay factor. All right, so now it says write the decay of the function as a percent. Well, so this is kind of like what we did in the last time. Remember how we identified the number that we had started with, and then we had to identify the rate? We're going to do the same concept here, but this one's we'll just do all 3 of them here. We're going to do A, R, and we're going to leave it at that. I mean, 2 of them. So what I started with is 40. That's pretty easy. Now, recall your equation. It's going to be A times 1 minus R to the T power. All right, that's my equation. So I need to figure out what R is. Well, this is 0.78. So let's find out what the difference is with that. So if I were to go 1 minus 0.78, that gives me 0.22. That means that the actual rate, my actual percentage here is 22%. Okay, pretty simple, because that's the difference. It went from a 1 down to a 7.78, and that's basically, it went down 22%. All right, same concept on this one. What I'm starting with, in this case, is 5. My rate is on this is a little bit more difficult because this is a fraction. But this is 1 minus 2/5. And this one should be a very simple one. You can do in your head. That should give you 3/5. All right, because if we were to change this into a fraction, it would be 5 over 5. So 5/5 minus 2/5 is 3/5. And we can change that into a decimal real quickly. That's 0.6. And we know how to change 0.6 into a percent by using moving our decimal over twice to give us 60%. So this particular problem has a rate of decay, a rate of 60%. All right. Number 7, it says the mass of a radioactive element is 35 milligrams. The mass of the element decreases 12.9% every year. Write a function that represents this equation. Well, let's start with our basic thing. We know that we are going to subtract each time. So what we start with is our 35. 1 minus, and this is going to be 0.2129 because we have to change that into a decimal. Then let's find out what that's equal to. 1 minus 0.129. I have 8. So our final equation is y is equal to 35 times 0.871 to the t power. Now it's asking me to find it in 4 years. So basically I'm going to plug this in. So I already got the number 8.871. I'm going to raise that to the 4th power because that's my years. And then I'm going to multiply it by what I started with. So after 4 years, and according to this, it needs to the 10th. So it should be 20.1, what was our units? Milligrams. And that's pretty much it. There's really nothing overly complicated with decay. If you understand growth, it's just the opposite. Instead of doing a plus R, it's doing a minus R. And that's it for this video. As always, you know how to find me. Bye-bye.